there. So we are going to chat about graphing in three forms today. So we'll talk about graphing in standard form, graphing in vertex form, and graphing in factored form for quadratic functions. So standard form is our form that looks like ax squared plus bx plus c is equal to y. Our vertex form is y is equal to a x minus h squared plus k. And our factored form is y is equal to a x minus r times x minus s. So each of these forms sort of have their own, we could say, sort of special piece to them. This a value is very important and very similar for all three forms. So the a value, if it's positive, it gives me a concave up parabola, so one that looks like a smile almost. If I have a negative a value, it gives me a concave down parabola, so my kind of parabola that looks like a frown. So that's for all three of these forms. So the sign of the a value determines the concavity of the parabola. It also determines how skinny or narrow or sort of wide or fat my parabola is. So having an a value that is a rational number in between 0 and 1 will end up giving me a very wide parabola, whereas having an a value that's a large integer will end up giving me a very skinny parabola, and we'll see that as we go through and graph some of these functions. So looking specifically at standard form alone, aside from the a value, this c value that's staring right at us here, this is always our y-intercept of our graph. Because if I plug in 0 for x here and here, I'm just left with that c value. In order to find the vertex, I can use the equation x is equal to negative b over 2a, using this, of course, as my b value and this as my a value here. That will give me the x coordinate of my vertex. So these are just sort of a few notes that you can take, and then we'll do some examples with all three forms a little later on. So that's a little rundown for standard form. For vertex form, it's called vertex form because looking at this form, the vertex is staring right at us, and it's h comma k. So this h right here and this k right here. Same information about the a value. If it's positive, it's concave up. If it's negative, it's concave down. And then we can plug in a few points here, or we can set this equal to 0 in order to find some roots for graphing. Lastly, factored form is nicely called factored form because this looks like a factored quadratic because it is a factored quadratic. So my r and my s value are my x-intercepts here. So we can set this equal to 0, x minus r is equal to 0, and x minus s is equal to 0, and that will give me my roots. I also know that exactly halfway between r and s, so r plus s divided by 2, will give me the x coordinate of my vertex as well. So that's just a little information about these three forms and sort of what they look like. We'll start here with graphing in vertex form. So looking at this y equals a x minus h squared plus k, my vertex here will be 2 comma 2. So notice before I said that my vertex is h comma k and not negative h comma k. So it's the opposite of whatever is in here. So since this looks like a negative 2, my vertex is 2 comma 2. Which makes my AOS, or my axis of symmetry, x is equal to 2. My y-intercept, I can plug 0 in for x and I can evaluate. So y is equal to 0 minus 2 squared plus 2. And this is going to give me 4 plus 2, which is going to give me 6. So 0 comma 6 is my y-intercept, so I'll go ahead and plot that. Over 2 and up 2 is my vertex. And I know that this is a concave up parabola because my a value here is positive. So I know that my domain, well, since this is a quadratic, My domain will be all real numbers, and my range is y values that are greater than or equal to 2. So since this here is where my vertex is, I know that my values will exist from there and above. My concavity is up, and since this is concave up and my range is y values that are greater than or equal to 2, I know that there's no roots. I can also solve for those roots algebraically by saying 0 is equal to x minus 2 squared plus 2. Subtract 2 from both sides and take the square root of both sides. And here, taking the square root of this negative number will tell me that I have no real roots. So then what I can do is I can go ahead and use symmetry and plot this other point right here, because I know that my axis of symmetry is at y, or at x is equal to 2. And I can come in and I can nicely sketch my concave up function. So we'll do this one more time with this example that's down here. My vertex here is -1, -3. So -1, -3, here is my vertex. My axis of symmetry is at x is equal to -1. My y-intercept, I have f of x is -2. 0 plus 1 squared minus 3. That's going to give me -2 times 1 minus 3. And this will give me -2 minus 3, which will put me down here at -5. So 0, -5 is my y-intercept. I can use symmetry and plot this other point right here. This is a parabola, so my domain is all real numbers, and I'll use the y-coordinate of my vertex to figure out my range, so y values that are less than or equal to -3. I'm concave down because my a value here is negative, and I again have no roots. And I can solve for those roots algebraically. 0 is -2, x plus 1 squared minus 3. Add 3 to both sides. And divide both sides by -2. And here I have -3/2 is equal to x plus 1 squared. And taking the square root again of that negative number will yield 0 roots, or no roots, I should say. And I can go ahead and sketch in my function and make sure that it's nice and curvy down at the vertex and not a V, so it doesn't look like an absolute value function. So here are two graphs that are an example of graphing in vertex form.